Hi everyone. We are a research team from Zhejiang University. Today we will present our late-breaking work titled NUMAT, Pneumatic Interaction System for Infant Sleep Safety, using shape-changing interfaces. We propose the NUMAT, an interactive shape-changing system integrating sensors and pneumatic drives to help ensure infant sleep safety through novel human-computer interaction. To understand this issue better, we first look at the report for the Early Childcare Research Network. There are about 3,500 sleep-related deaths among U.S. infants each year. One study found that 2 out of 15 reported infant deaths involved infants having been placed in a prone position, and 87%, had rolled into a prone position from either the supine or side position. And studies have found that a side sleeping position is unstable and increases the chance that infants will roll onto their stomachs, the sleep position associated with the highest risk of sudden infant death syndrome, SIDS. Thus, it is important to keep the infant in a safe position during sleep. Next, I'll describe how NUMAT works for a few usage scenarios. After being fed, infants are usually placed on the mat to rest. Before the infant is placed on the mat, the NUMAT runs an inflation procedure in advance so that the infant is placed on an inclined plane, and this position will be maintained for 15 minutes, according to the doctor's clinical advice. This process is to prevent the infant from choking on milk. A temperature sensor and a pressure sensor are placed on the inflatable unit that the infant will come into contact with when laying on his side. If the infant's position is not correct, the inflatable units on the opposite side will inflate tidally to adjust the infant's sleeping position. So, how can NUMAT autonomously adjust the infant's position? The NUMAT is composed of 4 main parts. A. 9 groups of inflatable units connected by tubes so that the infant can be placed on the inflatable units. B. A control unit. C. A group of integrated analog digital signal sensor units. D. The computer works remotely for real-time data acquisition and processing. Then the control units can be attached to the side of the NUMAT via tubes. The system has integrated sensors and inflatable units. The pressure sensor, temperature sensor, and ultrasonic sensor read the pressure, temperature, and distance between the infant and the mat respectively. And liquid sensor is used to detect whether infant, sudden onset, acute, and severe choking milk. All sensors provide sensory input to the system so that the NUMAT can autonomously adjust a dangerous sleeping posture by shape changing. The NUMAT is divided into 9 specific areas. Division of the NUMAT based on the infant's body structure to achieve the purpose of more precise adjustment of the infant's sleeping position and a better interactive experience. 1. Currently, to use the NUMAT, infants would be in a state of pre-sleep or sleep generally, but the pneumatic drivers of the interactive system will produce some decibels of noise, which may disturb sleep. To address this problem, we plan to have the pneumatic drivers fixed in a box made of sound-absorbing material. 2. The weight of the baby doll used in the experiment is much lower than that of a newborn. In addition, the doll was static and remained passive throughout the test. The detection effect of the system on posture changes is uncertain to real newborns, so it would be beneficial to collaborate and work together with various stakeholders, such as physicians and infants' parents, to design, improve, and evaluate NUMAT in practice. So with that, we think every family with newborns in the future should be equipped with something like NUMAT to help ensure infant sleep safety. For any questions, feel free to ask me in following session or reach out to me by email. And for technical detail and result, you can read our paper. I'm excited to hear all your questions and suggestions. That's all. Thank you.